These are the chapter 6 slides for the normal distribution, and I have a lot of slides here. My hope is that this gives you an overall intuition about the normal distribution, and then when we get into the activity sheet, the notes sheets, then you can get into the calculations a little bit more. So the second slide shows that shoe size is normally distributed. And what does that mean? Well, a normal distribution is also known as a bell-shaped distribution. X is a continuous random variable, so that means we could have decimals in there as well as whole numbers. I guess I could see how shoe sizes have decimals. And for a normal distribution, the middle is the mean or average, which we write as mu, and sigma is the standard deviation. So a normal distribution means that you have a lot of people close to the middle, lots of medium shoe sizes in the middle. So these are the normal people, quote unquote, and then you have big shoes over here, not very many really big shoes, and not really many tiny shoes over here. Here is a distribution that is not bell-shaped. So a lot of people in the lower income brackets and fewer people as you get into higher income brackets. Here is another distribution, U.S. population by age. It kind of tapers off as you get older, and there are peaks. There are lots of millennials and lots of boomers. So it's kind of bell-shaped on the right-hand side. That's sort of bell-shaped, but then it's kind of flat over here, so it's almost uniform on the left-hand side. Grading on a curve actually refers to the normal distribution. These are not normally distributed scores. These were scores from a previous statistics course, and we had a lot of A's and B's and not very many F's, D's, and C's in that class. So this was not a normal distribution. A normal distribution would be a lot of C's, not that many A's, and not that many F's. Here are normally distributed heights. So super tall people over here, super short people over here, lots of average people right in the middle. So the two parameters are mu and sigma. The mean is the median, is the mode in this distribution. So they're all the same. The most popular value is the median, the middle value, and it's also the mean of the distribution. And then sigma is the standard deviation. The distribution is symmetric. It's the same on both sides. It's not skewed one way or the other. What is the total area under the curve? So I did not write the word total here, but that's what I meant. Total area of the curve is 1, because it's 100% of all the data values are under that curve. And the second question is, what is the probability that a random data value is smaller than the mean? So if we draw a line right in the middle for the mean, then exactly 50% or 0.50 probability is lower than that. So these are the values that are below the mean. What is the probability that X is equal to the mean? What is the area that I just shaded? Well, we talked earlier about the fact that in a continuous probability distribution, the probability of a single value is 0. So that's going to be 0. Sigma represents the standard deviation. So this is a little trickier than talking about mu, but think about the word deviate. So you are getting a little bit weirder, 1 standard deviation, 2 standard deviations, 3 standard deviations away from the mean, getting weirder and weirder. In this case, larger than average, or you could be getting smaller and smaller away from average as well. So deviation means how far away from the mean are you? The empirical rule talks about, well, this is based off of the function that defines the normal distribution. And using calculus, they find the area under the curve, and exactly 68% of the data is in this region. So 68% of the data is within 1 standard deviation of the mean, plus or minus 1 standard deviation. 95% of the data is plus or minus 2 standard deviations, and then 99.7% of the data is within 3 standard deviations. And there are data values out here beyond 3 standard deviations, but not very many, very, very few. The vast majority of the data values are closer to the mean. So this is showing that same information just in a different image. In the previous image we had 0 in the middle. Now I have mu in the middle, and mu plus sigma, or mu minus sigma. But this still really means the same thing. It's within 1 standard deviation of the mean. And I abbreviate standard deviation like that, STD, DEV, of the mu, of mean. 95% are within 2 standard deviations, 99.7% are within 3 standard deviations of the mean. And I think I wanted to jump into our next video and start talking about IQ. So we'll cut this one off here.